Okay, guys, welcome back. I see only 3 people. That's why I just want to wait a couple, maybe 1 or 2 minutes for others to join us. So before that, if you have any question regarding quiz 3 or any other quizzes, we can discuss about it. So I got some students saying they were logged out of the quiz. I think there was some technical issue. I don't know exactly why, but they reported some technical issue. So if there is something I can do, we can discuss about it. So if you guys have any specific question regarding quizzes and assignments, you are welcome to ask, write on the chat or just speak up. So we'll discuss about it until others join the lesson. So our lesson for today is 3.5, division of algebraic expression. We are going to talk about properties of exponent and use them in dividing polynomials. And finally, we'll see how to divide a polynomial by another polynomial. Okay, so if you have any question, I'll use the next 2 minutes for that. Otherwise, I'll start the lesson for today. Okay, guys, I think you guys are good with the way the class is going. So I will start our lesson for today. So the lesson is 3.5, division of algebraic expressions. So the objectives are to introduce and apply rules of exponent when dividing algebraic expressions. Basically, we apply rules of exponent when we divide by polynomial by monomial expression. That we'll be able to divide algebraic expressions. That's the main objective. Okay. Now, last time we saw properties of exponent. Today we're going to review it again. So there are several properties of exponents. The main property we are going to use for today are these 3 or 4 properties of exponent. So if you have questions, because we are going to learn division, quotient of exponents, you subtract the powers. So subtract the power. So we subtract the power. A to the power of m divided by a to the power of n equals a to the power of m minus n. Any number to the power of 0 is 1. So always remember, any number to the power of 0 is 1. So that is a property is called definition of zero exponent, zero exponent. So it is very important in simplifying expressions. So if you combine this two, let me combine this two, okay, and let me show you an example. So let's say I have x squared divided by x squared. Now the first one says if you have division of exponent, we subtract the power. So it will be x to the power of 2 minus 2. So x to the power of 2, x to the power of 2. So 2 minus 2 is x to the power of 0. 2 minus 2 is 0. So we know any number power of 0 is 1. So technically, x squared cancel x squared and you will have 1. When you divide the same number, it divides into 1. or if you apply the properties, that's exactly what you get. Okay. Now the next one says a to the power of negative n equals 1 over a to the power of n. If you have a negative exponent in the numerator, it goes to the denominator and becomes positive. To the contrary, if you have a negative exponent in the denominator, it will go to the numerator and becomes a positive exponent. So this two says if you have a negative exponent, it goes to the denominator, becomes a positive. If you have a negative exponent in the denominator, it goes to the numerator and becomes positive. So I can combine these two and show you example. So let's say I have x to the power of negative 5 over y to the power of negative 3. If you see these two, both of them are negative exponents. One is in the numerator. I'll bring that to the denominator and becomes x to the power of 5, becomes positive. And y is in the denominator. I'll move it to the numerator and becomes positive. So we usually change negative exponents into positive at the end because that's the proper way to write exponents. Okay, we don't usually leave negative exponents, so you have to write it in terms of positive exponent. Okay, so these are the properties of exponents. So the product rule, you have product of two exponents, you add power. Add the powers. Okay. If you have exponent, power of power, you multiply the exponents. Okay. So these are the properties you have to remember. Now let's apply these properties and divide a monomial by a monomial. So monomial is a single expression without addition or subtraction. It's just a multiplication of a number or any algebraic expressions with variable. So let's see the first one here. So I have 5 or 6 examples. So I'll do the first two and I'll give you time to work on the next 2 problems. Then we'll do one each on the last 2 problems. Okay, if you see the next problem, so 3 is by itself, y is by itself, a is by itself. So they will not change. So the only thing we will change is the x's. So the x will cancel out. X cancel x, or x to the power of 1 minus 1, which would be x to the power of 0. That would be 1. So this x cancels x. So the expression reduced to 3y over a. So that's simple. Okay? So if you have numbers, simplify the numbers. If you have any common factor, simplify the common. So if it is just a monomial with degree 1, it is easy to cancel out. Now if you see the next one, again 10 cancels 10. 10 divided by 10 is 1. Again, a will cancel a. So we are left with b. So technically 10 divided by 10 is 1. So 1 times b will be just b. Okay. Now try number 3. So what do you think is the answer for number 3? Excellent. Jasmine has a. Diana has 1 over a. Any different answer? Excellent, Deborah. 1 over a. Excellent, excellent, guys. So you guys got the correct answer. So this here is the most common mistake. So we know x cancels x. When x cancels x, what we mean by is x divided by x is 1. It doesn't go away, so it becomes 1. Okay, that's why you have 1 in the numerator. It's not just a, because 1 will be in the numerator over a in the denominator. Okay, so that's why we have 1 over a. Excellent. Now the next one, you divide by 4. 16 divided by 4 is negative 4. Now if you see here a squared over a, you can apply properties of exponent. That means a to the power of 2 minus 1. which would be a the power of 1, which is a. Or you can see it like this. A squared is a times a, and you are dividing it by a. So one a cancels another a, and you have a. So we have a and we have b. That's it. Very simple. Okay. Okay. Now I'll try number 5, and I'll give you time to try number 6. Now, if you see number 5, this is how you should approach the problem. So first, you divide the numbers. Negative 20 by negative 4. 20 divided by 4 is 5. Negative divided by negative is positive. Then for the variables, we apply properties of exponents. So x to the power of 3 minus 2. So because this is division, if you have questions, you subtract the powers. Times y the power of, now if you see here, we have 3 in the numerator, 1 in the denominator. 3 minus 1. Times z the power of 3 minus 5. Okay. So we have y the power of 3 minus 1 and z the power of 3 minus 5. Just the top minus the bottom. So let's simplify this expression. 5 x the power of 3 minus 2 is 1, so which is basically x. Y the power of 3 minus 1 is 2, and z the power of 3 minus 5 is negative 2. Okay. Now negative exponents goes to the denominator and becomes positive. So you have 5x y squared divided by z squared. That's the final answer. So whenever you have a negative exponent, it goes to the denominator and becomes positive exponent. Any question on this example? Yeah, so when you cancel out, it will be 1. When you cancel out, it's always 1. Don't forget that. Yes, Hugo, it's wrong. If you write, sorry, I didn't saw that. I'm responding to Hugo. If you just write a, that's wrong, because x divided by x is 1. So you have 1 over a. Okay, guys, try the last example. Everyone try the last example. I'll give you 3 minutes. Doesn't take more than 2 minutes. So let me rewrite the expression. So division can be written as a fraction. So you guys already know that. Negative 18 x cubed y would be divided by negative 12 x y the power of 4. Okay. Now simplify the number and reduce the fraction. The variables, and write the answer as a positive exponent. So what do you think is the answer for this one? So we still have 2 minutes. X squared. Okay, good, Abby. So you have 9 by 3 by 3x squared 2y the power of 3. Excellent, Deborah. So Abby, you divided by 2 different numbers. I think you divided the top by 2 and the bottom by 3. So it should be divided by the same numbers. I think 9 over 4. Yeah, I should just check the number. Yeah, check it again. It's okay. No problem, Norma. So make sure you are in a good connection, guys. And I will record this video, and you can watch it again if you're interested. Excellent. So you guys got the correct answer. So Abby, Deborah, and Hugo is writing. So what you can do is just divide the top and the bottom by 6. That will reduce the expression. So 18 divided by 6 is 3. 12 divided by 6 is 2. Now negative divided by negative is positive. Now for the variables, you have x to the power of 3 minus x to the power of 1. So 3 minus 1. For y, I have y to the power of 1 minus 4. So you don't have to do this every time. So because you know 1x will be cancelled out here, and I have 2 x's. 1x here cancels out, and I have 3 y's. So you can do it right away. So it becomes 3x to the second power, 2y to the third power. Okay, but this is the standard way to do it. That's why I'm showing you the properties, just to practice how to use the properties of exponents. So let's see the final answer. So you have x to the power of 2 and y to the power of negative 3. So I told you negative exponent goes to the denominator. So in the numerator we have 3x squared, and in the denominator we will have 2y to the third power. Okay, that's how you simplify expressions like that. Any question? Okay, let's move. Now next we will see how to divide a polynomial by a monomial. Earlier we saw monomial divided by monomial. Now we'll see how to divide a polynomial by a polynomial by monomial. Now if you see A, the denominator is a common denominator for both expressions. So when you have a polynomial divided by a monomial, what you have to do is each term, in this case, if you see here, x cubed will be divided by x, and x squared will be divided by x. Okay? So x cubed divided by x is x squared. X squared divided by x is just x. That's the final answer. So all you have to do is divide each term by the given monomial and simplify the expression. Okay, so that's the final answer. Yeah, it's the same concept, similar concept. Okay. Now I'm not using the rules if you see on the example. So I see there are 2 x's and I'm taking away 1 x. Then you'll have x. I see x cubed divided by x. I have 3 x's. I'm taking away 1 x, so I have 2 x's. So you have x squared. So let's see the next example. So we do the same thing. I have 4x squared will be divided by 2xy minus 2xy cubed will be divided by 2xy. Okay, then plus xy will be divided by 2xy. Okay, now I want you to simplify each expression and write your answer. Okay, guys, simplify each expression. At least give me the first 4x over y. Okay, I see x over y, but if you see, we have 4 divided by 2. 4 divided by 2. Yeah, I know you got x and y, right? And so 4 divided by 2 will be 2. So you have to simplify the numbers also. So 4 divided by 2 is 2. So I have 2. And x squared divided by x is x. So you're taking away 1x, but the y will stay in the denominator. Now, if you see the second one, 2x will be cancelled out. 2x, x also cancels x. 2 cancels 2. I have y cubed divided by y. So 3y's, and you are taking away 1y. So 3 minus 1 will be 2. So I have y squared by itself. And what about the last expression? Anyone write the last expression? Excellent. Dana, your expressions are correct, but don't forget the number. Excellent, 1/2. Yep. Any other answer for the last expression? And do you know how we got it? 1/2. Okay, if you see here, x, y will be cancelled out. So x cancels x, y cancels y. So when we say y cancels y, technically y divided by 1, y is 1. So we have 1 in the numerator divided by 2. So that's the simplified expression. 2x over y minus y squared plus 1/2. Okay. Now for the last example, I'll give you 3 minutes. Then I will do the problem together. We'll do the problem together. So try the problem first. So let me write it down for you. X cubed divided by negative x plus x squared divided by negative x minus 1 divided by negative x. Okay, write down the terms. First, what is x cubed divided by negative x? And x squared divided by negative x. So you keep adding the exponents. Remember, we subtract exponents. When you have division, you subtract exponent. We add exponents when you have multiplication. So the negative, I see the negative is not exponent, it's just coefficient. Yeah, that's the difference. So if it is an exponent, it will be different. But this negative is technically -1, coefficient in front of x. It's not exponent. Okay, so you have this negative, so the exponent would be negative. So 3 minus 1. So this is x to the power of 1. So 3 minus 1 is 2. So I have x to the power of 2. In the second one, again I have negative because positive divided by negative is negative. X to the power of 2 minus 1. So be just x. 2 x's, you take away 1 x. And the next one, negative divided by negative is positive, and we have a number divided by x, so we can't divide the 2, so it'll be just 1/x. So that's the final expression. Okay, so always remember x to the power of n over x to the power of m is x to the power of n minus n. Okay, any questions so far? Any question? So the negative is not exponent. So some of we got 4. If it was negative exponent, that is correct. But this -1 is coefficient. So I think you subtracted 3 minus -1, that gives you 4. Okay. Any question before I move to the next topic? Re-explain the last. Okay. So so we did the same thing. If you see here, we have x cubed, and we divide it by -x. So I have, let me show you what it looks like. So I have x cubed, and I have to divide it by -x. So you take x cubed, you divide it by -x. Okay. So x cubed is technically x times x times x, and I have -x here. So I have 3 x's in the top, 1 x at the bottom. So 1 x will be cancelled out. So I'll be left with 2 x's. And we have negative here. Don't forget we have negative. So negative x squared. So x times x is x squared. That's why we got -x squared. So in the second one, we have x squared divided by -x. So again, 1x, and at the top 2 x's. So I have x and x. I have -x. Don't forget it is negative. So 1x cancels out. So I have just -x because of this negative. That is how you can imagine the division. Okay. Is that clear now? Oh, you don't see? I see it on my page, so I don't know. Yeah, I'm recording it, so you can go back and refer it again. Okay, Norma. So I'm recording the video, so you can watch it again. Okay, let's continue. Or use another. If you are using Chrome or Explorer, just change it and log in again, so it should work. Okay, now let's go to the next topic. So the next topic is polynomial long division. We call it long division, a division of polynomial by another polynomial. So this example is just a polynomial divided by a monomial, single term. We'll see a polynomial divided by binomial or trinomial. Okay. Now, in this example, polynomial division is similar to division in numbers. So first, I'll show you how we do a division, long division in numbers. So that what you know from middle school. And we're going to establish the same steps for long division in polynomials. Okay. So when we divide, so let me do the numbers first, and or I can do it parallel. I don't know which one is better. So give me a moment. So let me reduce the number because this number takes a lot of steps. Let me change the number here. Let's say I have 675. Okay, just long division. So I will establish the same steps for numbers, division in numbers with division in polynomial. So when we divide polynomial by another polynomial with more than one terms, like binomial or trinomial, it is much more convenient to use long division. And long division in numbers has similar pattern or steps as long division in expressions or in polynomial. So I'll do it parallelly so that you can see what I'm doing. Okay. Now, let's start this problem. The one on the left is long division in numbers. So when you divide long division, the numerator goes inside here, 675, and the divisor 3 goes outside here. Okay. So we do the same for the polynomial. So I need a space here. Okay. So the 2x squared plus 5x minus 2, sorry, minus 3 goes inside here, and 2x minus 1 goes outside here. Now, when we divide long division with numbers, what you have to do is find if 3 goes to 6, how many times? That means you'll find a factor which multiply 3 to give you a 6. That to find that number, all you have to do is divide 6 by 3, which is 2. So 2 times 3 is 6. That's how you figure out that factor or that number. So we do the same for polynomials. And in polynomials, what you do is you take the first terms, the 2x squared and the 2x. So I'll divide the 2x squared by the 2x. So 2 cancels 2, and x squared divided by x is just x. So you have 2 x's, 1 x cancels out. So this cancels out. X squared divided by x is x. Now this number 2 goes up here, if you remember in long division. Then we back multiply. So multiply here. That's the step, multiply. So first find the factor, then multiply. So 2 times 3 is 6. Now we don't write 6. We subtract or change the sign. So we change the sign here to negative. You see here. We subtract or change the sign. Change sign. Then we subtract. This will cancel out, will be 0 and bring down the 75. 7 and 5 comes down. And we keep repeating the same step. So what we do is find a factor, multiply by the divisor, in this case 3, 2 times 3, and then change the sign and add the 2. So 6 minus 6, it will cancel out, it becomes 0, and we have 75. We do the same thing for the polynomial. So I will put the x, which is the factor, up here. Then back multiply. So when you multiply 2 terms. So the 2x and the negative 1. So x times 2x is 2x squared, because x times x is x squared, and I'll switch the sign. So don't forget to change the sign. That's the step, important step. It says change the sign. X times negative 1 is negative x, and also we switch the sign. So we change it into plus. Okay, so we add the 2. So 2x squared cancels 2x squared becomes 0. 5x plus x is 6x, and I'll bring the 3 like I brought the 75. So I bring down the 3. Okay, now again we continue the same steps. So change the sign. So this is multiply by negative, or change the sign. This one is multiplication. So multiply, then change the sign. Okay, so we keep repeating this step until we get a degree less than 1. So or until you get a number in this case. Now let's do the for the number. So again, we have to find how much times 3 goes to 7. 7 by 3, it goes 2 times. 2 times 3 is 6. So 2 times 3 is 6. Again, we subtract. We switch the sign. 7 minus 6 is 1, and I'll bring down the 5. Okay. So we do the same here. So I have the 6x. So the next factor will be found by dividing 6x by 2x. So always the leading term will be divided by the leading term in the divisor, which is in this case 2x minus 1. So 6 divided by 2 is 3. X cancels x. So I have 3. So 3 goes up here. And back multiply. 3 times 2 is 6x. And we change the sign or switch the sign. It becomes minus. 3 times negative 1 is negative 3. And we switch the sign to plus 3. Okay. So 6 minus 6 is 0. It will cancel out. Negative 3 plus 3 is 0. So this number is called the remainder. Remainder. And this is the quotient. X plus 3 is the quotient. So Q for quotient. Now for the number we are not done. You see, still we have 15. So I have to divide 15 goes to 3 5 times. So I have to add 5 here. 5 multiply by 3 is 15. So minus 15. So you have 0. So that's the remainder. So the quotient of 675 divided by 3 is 225. So the two are parallel, the two are the same. So these are the steps. Find a factor which multiply to give you the leading term. So in this case, if you see you have 2x squared would be divided by the leading term 2x. That goes up in the division, and we multiply the divisor to x minus 1 by that by x, and we switch the sign, then add each column. And we keep doing this until we get a degree less than x. In this case, until you get a number. Okay. I know this looks very complex and very long process. Let's do more examples so that you will understand it. Okay, let's do another example. So this example is just to show you the parallel between long division in numbers and long division in polynomials. Okay, now let's do another example. Oh. Okay, now before I move to, so this is to stabilize, to establish the similarity between long division in numbers and long division in polynomials. But when we do long division, there's something you have to remember. So the polynomial has to be in standard form. Whichever polynomial is divided, it has to be in standard form. Now the question is, how do we consider if a polynomial is in standard form? So a polynomial is in standard form if it satisfies these two conditions. One, if the degrees are in decreasing order. The degree of the terms are in decreasing order. Decreasing order. So the higher the degree, so you start from the highest degree and goes down until you get a constant or smallest, becomes in decreasing order. Okay. Now the next one is for missing term. We apply. So if there is any missing degree, for example, you have the highest degree is 5, and if you are missing degree 3, you have to include 0 the power of x the power of 3. So for missing degree, include 0 x the power of n. Okay, so this is important when you do polynomial long division. So if the polynomial include this two, it is in standard form. If it is in decreasing order of the degree, and if there is any missing degree in between, and if you add 0 x to the power of n, that polynomial becomes in standard form. Now, if you see this example, it says write the polynomial in standard form. Now, the first thing you do is just look at the polynomial and see or figure out the highest exponent. So the highest exponent is x to the power of 5. So that would be the starting term. So, or we call it the leading term, 11 x to the power of 5. So we start from there. So from 5, the next number will be 4. So I have negative 5 x to the power of 4. Now, if you see, we don't have x to the power of 3. If you have a missing degree, what you have to do is include 0 x to the power of n. In this case, we are missing x to the power of 3, so we have 0 x to the power of 3. Then we have x to the power of 2, so 3 x to the power of 2. And we don't have x, so the degree 1, we don't have degree 1. So again, we have to include 0x. Finally, we have the constant 2. So this is the standard form of this polynomial. So if you are missing a term, you include 0 to the power of xn. If you have degrees in, if the degrees are not in descending or decreasing order, you have to write them in decreasing order. Okay. So when you do polynomial division, it's very important to do it, to have the polynomial in standard form. That's why I have this slide. You guys understood how to write a polynomial in standard form? If it is clear, just type yes or no. If you need more, I can explain it again. So two things always remember. The degree has to be in decreasing order, and if there is any missing term in between, you have to include 0 the power of x the power. In this case, we are missing x the power of 3, so I put 0 x the power. If you are missing x, you have to put 0 x. Okay? So because it will be very important when you do addition, division of polynomial. Okay, now let's see the next example. So we have this example. It looks very long, but we are going to apply the same 3 steps. Figure out any factor that multiply the 2x to give you the leading term. That back multiplies, and we switch the sign, then add h rows. So we keep repeating this until we get a degree less than 1 in this case, because the divisor is 2x plus 7. So we keep dividing until we get a number at the end. Okay, now we put the 6x to the power 4 plus 15x cubed minus 25x squared. We are not missing any term. Plus minus 22x. So this is a standard form. You see here. Plus 21. So we don't have to rearrange anything. We don't have to add zeros because it is in decreasing order and all the terms are present. Now, these are the factors we are looking for. First, we divide 6x to the power 4 by 2x to the power 4. So 6x to the power 4 divided by 2x. So 6 divided by 2 is 3. X to the power 4 divided by x is x to the power 3. So you have 4 x's and you are taking away 1x. So this goes up here, 3x to the power 3. So I told you we back multiply and subtract, switch the sign. So 3x to the power of 3 times 2x. So 3 times 3 is 6. X to the third power times x is x to the fourth power. Now this is positive. Don't forget to switch the sign. So we change it into negative. Again, we multiply 3 by 7, which is 21, and we have x cubed. 21x cubed. Then add the columns. So 6x to the power 4 minus 6x to the power 4. This will cancel out. Oh, sorry. I forget to change the sign here. Don't forget to switch the sign. 3 times 7 is 21. So we switch the sign to negative 21x to the power of 3. Don't forget to switch the sign. That's very important step. So this will cancel out. 15 minus 21 is negative 6 x cubed. Then bring down all this. Minus 25 x squared minus 22x plus 21. Now the next factor will be negative 6x cubed divided by 2x. Okay. So negative 6 divided by 2 is negative 3. X cubed, so you have 3 x's and you're taking away 1, so it'd be x to the power of 2. So the next expression becomes negative 3x squared. Now we back multiply and switch the sign. So negative 3 times 2 is negative 6, and we change it into plus 6. X squared times x is x cubed. Negative 3 times 7 is negative 21. And we have x squared. And we switch the sign to plus. So both of them are negative and we switch them to plus. So don't forget to switch the sign, okay? So negative 6 plus 6, this will cancel out. Usually the first terms will be cancelled out, always actually. It has to be cancelled out. So negative 21 plus 20, negative 25 plus 21 is negative 4 x squared minus 22x plus 21. Okay. So again, we have another negative 4x squared. So I have to divide negative 4x squared by 2x to get the next factor, which would be negative 4 divided by 2 is negative 2. X squared divided by x is x. So you're taking away 1x. So negative 2x here. We are doing the same step until we get a remainder, which will be a constant number. So negative 2 times negative 2 is negative 4. So we switch it into plus 4. Then x times x is x squared. So it becomes plus 4x squared. Negative 2x times 7 will be negative 14x. So we change it into plus again. So this cancels out. Negative 22 plus 14 is negative 8, I think. 6 plus 2, yeah, negative 8x plus 21. So negative 8x divided by 2x again. So those would be the last factor. So negative 8 divided by 2 is negative 4. So the negative 4 goes up here. Negative 4 times 2x is negative 8x. And we switch the sign to plus. Negative 4 times 7 is negative 28. And we switch it to plus. Okay. So this will cancel out. And 21 plus 28 is 49, I think. That is the remainder. Okay. Make sure you have the correct numbers. Oh, sorry guys, I didn't see. Is there anyone who caught a mistake on this one? Can you guys? No, there is nothing. I'm just trying to see if you guys were following me. Sometimes it is very hard when you're teaching in this online, and if everyone is following up. So if you see anything, any mistake, just try to point out. $14 supposed to be negative. Okay, so you have negative 2 times 7 is negative 14. So we switch the sign to positive. Yeah, so it should be positive. So always after you multiply, you switch the sign. If you get a negative, you switch the sign to positive. So the answer is correct. I'm just trying to check if you guys have been following me while I'm doing the problem. Now, this is how you write the answer. So if you are asked for the question, so this is the top is the question, and there's a remainder. So the answer is 3x to the power of 3 minus 3x squared minus 2x minus 4, then plus the remainder divided by the divisor, which is 2x plus 7. Okay. Specifically, if you are asked for the question, that the remainder, it is 49. The question is the top one, but when you write it like that. So the remainder divided by the divisor. Any question? I know this is long. I chose this example because it shows you the steps over and over. Like we do it 4 times. so that you can understand it better. Okay. Now, to check if you guys, whether you guys understood it or not, I will give you another example, relatively simple example, and I'll give you 5 minutes to work on it. Then after that, you type the answer on the chat, or I'll give you the whiteboard and you can write the answer on the whiteboard. So let's go to the next example and I'll give you 5 minutes on that. So 5 minutes to do it, 5 minutes to discuss the answer. Okay, so this is relatively simple. So the polynomials are standard form. You don't have to change anything. And all you have to do is just figure out all the factors on the right, multiply them, switch the sign, add the columns, and keep doing this until you get a number, which is the remainder. Okay, so 5 minutes from now. If you have any question, type on the chat. Okay. Okay, guys, we have 1 more minute. So I'll open the whiteboard here and type the question right here, if you can see it. Okay, guys, time's up for the problems. Anyone who can try this problem? I will open the whiteboard. Just type your answer on the whiteboard. Are you trying to do the problem? Is there anyone who would like to try the problem? If you like to try, just start working on the problem. So just open, you can type. Okay, let's do this. Let me ask you a question, and we can I can write. So you answer the question on the right hand side. First, the factors and oh, sorry, it's not typing properly for me to. You know, sometimes it's challenging to write on the whiteboard. Now the first number is x cubed divided by x, and it goes to how much? Excellent. I have answer here: x squared plus 5x plus 6x plus 6. Good, excellent. So I don't think you should have two x's at the same time, like 5x and 6x. One of the two should not be there. So anyways, we'll check it. But I think your answer is right. At least one of the two should not be there. Okay, yeah, good. So the first number, it goes to x squared. Now let me do it on the PowerPoint. It's easy to work on the PowerPoint. Sorry about that. So we said we have to set up the division. So you have x plus 2 here, x squared plus 3x squared minus 4x minus 12 here. First, this is x cubed. X cubed divided by x is x squared. So we have x squared here. When you back multiply, x squared times x is x cubed, and we change it into minus. X squared times 2 is 2x squared, and we change it into subtraction. So don't forget to change the sign. So we switch the sign to minus 2x squared. So this cancels out. 3x squared minus 2x squared is just x squared. Because 3 minus 2 is 1. Minus 4x minus 12. So x squared, again, divided by x is x. So I have x here. X times x is x squared. Don't forget to switch the sign to minus. X times 2 is 2x. I'll change it into minus 2x so that this cancels out. Negative 2x times, minus 2x is negative 6x, and bring down the negative 12. So I have negative 6x divided by, again, x, be negative 6. So x cancels x. So you have negative 6. So this becomes minus 6. Back multiply. Negative 6 times x is negative 6x. I have to change it into plus. Don't forget to change it into minus or plus, depending on the sign. So this is negative. I'll change it into plus. Negative 6 times 2 is negative 12. I'll change it into plus. So this cancels out. Negative 12 plus 12 is 0. So the remainder is 0. So the question is x squared plus x minus 6. Do you guys see the answer? And correct your answers. Oh, the video, when the class ends, the video will download by itself. So I'll close the lesson, it will automatically download it. So when you go back to that link or the class code, you'll see it has recording. It says recording 2, recording 3, recording something. Yep, excellent, Deborah. So always check. I think you added 3x squared and 2x squared. That's why you got 5. Okay, now let's go to one example where you have a polynomial divided by a trinomial. Okay, and after that, I'll take 8 minutes or 9 minutes to work on that problem, and the remaining time I'll set up a breakout room, and I'll give you one example, and I want you to discuss about it. So the remaining 10 minutes or 9 minutes. In the breakout room, we can discuss about the problem. We can talk about it. We can chat about it. And after that, we'll come back and we'll share the answer. Okay, I'll show you the answer, and that'll be the end of the lesson. Okay, now let me show you one example where we divide a polynomial by trinomial. So you see here, we have now the divisor is 3 terms. It's called trinomial. We have c squared minus c plus 1. Earlier we saw binomials, x plus 2 or 2x minus 1. In this case, we have trinomial, but the process will be the same. Now, first, the expression has to be in standard form. This is standard form. So if you see this expression, it's not in standard form. We are missing c cubed. So this should be in standard form, which is c to the power 4 plus 0c cubed plus 2c squared minus c plus 2. You guys see here, I have to include the c cubed. That's why we learn about the standard form of the polynomial. So we write the polynomial in this inside here. Now in standard form, c to the power 4 plus 0c cubed plus 2c squared minus c plus 2. And here outside we have c squared minus c plus 1. Now we are going to multiply 3 terms, trinomial. That's the only difference. Otherwise, it's the same thing. So we find the factors c to the power 4 divided by c to the power 2. We always divide the leading terms. So this divided by this. C to the power 4 divided by c squared. So 4 minus 2 is 2. So I have c to the power of 2. Okay, so the c to the power of 2 goes up here. So back multiply. So when you multiply, we are going to multiply 3 different terms. So we multiply c to the power of 2 times c to the power of 2, which would be c to the power of 4, and we switch the sign. Positive becomes negative. C to the power of 2 times c, which is c to the power of 3, and we have negative, so we change it into plus. Positive times negative is negative. Next, we have c to the power of 2 times 1, which is the c to the power of 2, which is positive c to the power of 2, and we change it into negative. We switch the sign, so don't forget to switch the sign. Okay, now we add all vertically. So this will cancel out. C to the power 4 minus c to the power 4. 0 plus 1 c to the power of 3 is c to the power of 3. I mean 0 c to the power of 3 plus 1 c to the power of 2 minus 1 is 1. So I have plus 1 c to the power of 2, and bring down the c and bring down the 2. The next will be c to the power of 3 divided by c to the power of 2, which is just c, because 3 minus 2 is 1. So I have, is that positive? Yeah, plus c. Back multiply, we do the same thing. C times c squared, c cubed, change it into subtraction. So c times c squared is c cubed. C times c is c squared, and we have negative. So we switch it into plus c squared. So c times negative c is negative c squared. We change it into plus. C times 1 is c, and we change it into minus. So add, this will cancel out. C squared plus c squared is 2c squared. Negative c minus c is negative 2c, and plus 2. Bring down the 2. So still we are not done. So we stop if the degree is less than c squared. So here c squared, 2c squared would be divided by c squared. Each time we are dividing by c squared, the leading term of the divisor. So that gives you 2. Yes. Yeah. So because c squared cancels out, you have 2. So plus 2 here. 2 times c squared is c, 2c squared, and we change it into minus. 2 times negative c is negative 2c, and we change it into plus. Don't forget that. So negative becomes positive. That is what you have to subtract. Technically, we are subtracting. We're switching sign, and adding is the same thing. Subtraction and adding, the opposite is the same thing. 2 times 1 is 2, so I will change it into minus 2. Okay, now we add 2c squared minus 2 squared, that will cancel out. Negative 2c plus 2c, again they are 0. 2 minus 2 is 0. 0 is our remainder. So that's 0. The remainder is 0, and the quotient becomes c squared plus c plus 2. So you can still divide a polynomial by trinomial, whatever term you have. You can still divide polynomials by using the same technique. We saw how to divide a polynomial by monomial. We saw how to divide a polynomial by binomial. Now this example shows you how to divide a polynomial by trinomial. So it doesn't matter how many terms you have. All you have to do is back multiply, switch the sign, add the column. But first figure out the factors, multiply by the divisor, switch the sign, add the columns. Okay. Okay. Now you guys understood this. We have one more question. Okay, one more slide. We have 11 minutes, so I'll take 1 minute to answer your questions, and I'll create a breakout room. Just assign randomly to three group of 3, and you guys just discuss the problem. How did you get 0? Okay, yeah, this is what I talked about writing standard for. If you are missing a term, because we don't have c cubed, 0 times c cubed is still 0. It doesn't exist. It doesn't affect the polynomial. If you are missing a term, just include 0. In this case, we are missing c cubed, so we include 0 c cubed. Because 0 times c cubed is still 0. It doesn't change the polynomial. It's just a placeholder. So that's what standard for form of polynomial is. Just to substitute and make a placeholder for c cubed, we just include 0 c cubed, which is technically 0. It doesn't change the polynomial. It's just a placeholder. Okay. Now let me try to create a breakout room. Okay. Before that, yes. So we'll take the next 6 minutes. Okay. So I'm assigning randomly. Can you guys hear me? I don't know. I'm assigning a breakout room. Okay, now you can go to your breakout room. I think so. And this is, oh, I don't know if you guys can. Oh, sorry, guys. I don't know if you have the.
You are currently the only person in this conference.
Oh, the recording will you'll find it in the same class code. So when you go to the link, it will download there. So it says 3 recording, 2 recording, and it will show you the date. Okay. Okay. So go to the breakout room, discuss the problem, and we have 7 minutes. And maybe the last 3 minutes, we'll discuss about the answer. If you guys have different answer, we'll talk about it. So go to your breakout room. You're welcome, Richard. Yes, so yeah, I'm Mr. You can call, don't worry. Just call me Mr. Soro. It's okay.
You are currently the only person in this conference.
I think you have to log out to see this. When you go out, and when you come back, and when you try to log into the classroom, you can see the recordings. Not here, okay? Okay, guys, I think we are back from the breakout room. There is only one room. Check your answer. We have 2 minutes. If you see anything, if you have any question on any step, or if you missed, oh, you don't hear anything. Can you guys hear me? Okay, okay, good. So I think we are back from the breakout room. So just check the answer and see if you guys can match your answer with this steps. So if you missed any step, try to fix that problem. And this is the lesson for today. We have 1 minute. If you have any question, I'll open the class for discussion. So far we've seen how to divide polynomial by monomial using the properties of exponent. Then we went to dividing a polynomial by binomial and trinomial using the method of long division. So this is the lesson for today. Any question? I will give you 1 more minute. So we have 1 minute. I mean, the video will be on in the class. So when you try to log in, just use the link I provided, or exam 1. Jasmine, do you have a specific question on exam 1? I don't think it will be for the whole class. So I'll give you option for exam 1. Exam 1 can be replaced. One of the exams can be replaced by the final exam. So when I prepare the final exam, if we get a better grade on the final exam, I'll drop one of the exams. So we have, I think I planned 4 exams. So that's the only thing I can do. Other than that, if you have a specific question, please reach out to me. And this is the lesson for today, and I'll see you guys on Thursday. Okay, bye-bye. Oh yeah, so exactly. So what happened was last time, if you remember, I moved a lesson from Tuesday to Thursday. So usually quizzes will include things we studied before midweek. If we studied something on Thursday, it will not be included in the quiz. And I'll communicate the content of the quizzes. So this week I already sent out an email. Quiz 4 will include from 3.1 to 3.4. Okay. Okay, bye. See you guys. Good night. Good night, Norma. Bye.